In this video, we vary the wavelength of the Moivre's cosine using the Moivre's cosine expansion, the Taylor series expansion, and the cotangent expansion. Begin with the values of W, data validation, list of items, from 6 to 8, so 5, 6, 7, 8. And the expansion of the Moivre's cosine, which is the summation of a times x to the power n, where n starts from 0 up to infinity. And the value of a is the real part of 0 plus wi raised to the power n over n factorial, which is this. So begin with the complex part. So array formula, complex. This is 0 plus wi, so 0, comma, w, which is this. That's the first one. So 0 plus 5i. And we continue, we raise it to the power n. So this will be IMPOWER. IMPOWER of n, where n is from 0 to infinity. And we want the real part. So we use IMREAL. Now that we have the real part, we can now divide this by, or show the denominator, which is the factorial. So divide by factorial of n. Now we can complete the first Taylor series expansion, which is array formula, series sum of the x values raised to the power n, where n starts from 0, incremented by 1, and the coefficient will be this range. That's the coefficient a. And we continue with the expansion. So we have the sine of x raised to the power w times the summation of b, which is this, cotangent of x raised to the power n, where b is combination, array formula, combination, w comma n, or w comma n. That's the first part, combine. Next, the second part is cosine w minus n pi over 2. So this is cosine 0.5 pi, 0.5 pi, times, so this is 0.5 pi, the quantity w minus n, and w minus n. And we close the cosine. We just close the cosine and close the array formula and enter. We correct this because our n is from 0 to w, so it's only from 0 to w. So if n is greater than w, if n is greater than w, 0. Otherwise, calculate. Now it's corrected. Now we can complete the expansion, array formula. Instead of SERIESSUM, now this is cotangent x raised to the power n. So cotangent of x raised to the power n. Cotangent x raised to the power n, where n starts from 0, incremented by 1. And the coefficient will be this range. Then enter. Now this is a cosine, so at x equals 0, it should be 1. So we correct that. If x equals 0, it should be 1. Otherwise, calculate. Now it's corrected. We continue. There's one more part, which is sine of x raised to the power w. So we multiply this by sine of x raised to the power w. Sine of x raised to the power w. Oh, this w. Sine of x raised to the power w. Now they're the same. We can now chart this. Insert chart. And we use cutter chart. Column is label. And for the series, we don't need this title. We replace it with the label showing the equation. So series, show the trend line. The type, polynomial. The degree, tenth. For the label, use the equation. And here's our trend line and polynomial. Of the cosine, where we can, the Moivre's cosine, where we can vary the wavelength. Suppose we vary the wavelength, changing the value w to 6. We shorten also the wavelength for the cotangent. Change the w here to 7. We can also do the same thing for the cotangent expansion to 7. They are the same. Change this to 8. We can also do the same thing. 8. Now they're the same. So this completes the use of the function SERIESSUM, cotangent, sine and cosine and combine, and data validation to generate or to change the wavelength of the Moivre's cosine.